Hello students, secondary 1 chemistry. Welcome you in a new lesson. Now unit 5 is still in our study, nuclear chemistry. The lesson now is nuclear binding energy. We know that the atom consists of a nucleus, contains protons and neutrons, and negatively charged electrons are circulating around this nucleus. The nucleus of the atom is containing protons and neutrons, and inside the nucleus the space is very small, and there is an attraction force between the nucleons. There is a force between them. This force is called nuclear force, the force working on combining the nucleons. This force prevents getting out of nucleons from the nucleus. There is also a more stronger force called strong binding force. This force binds the nucleons inside the nucleus. The strong binding force is occurring irrespective of the charge of the particle, which means that there is an attraction force between protons and protons. Although there is a repulsion between the protons, there is also strong binding force which tries to binding them together. Okay. There is also an attraction force between neutrons and neutrons, and an attraction force between protons and neutrons. This strong force is the reason. There is also a calculated mass of the atom, mass of the free protons and the neutrons. You can calculate the mass of the atom by adding the mass of all protons and neutrons. In this way you can calculate the mass of the nucleus or the atom as a whole. There is also an actual mass for the atom. The mass of the atom as measured by experiments. It was noted that there is a difference between the calculated mass of the atom and the actual mass of the same atom. Okay. Scientists thought why there is a difference between the calculated mass and the actual mass. They accounted for that by saying that there is a binding energy which is trying to maintain or to keep the constituents, or to bind the constituents of the nucleus. Okay. This energy is produced from the conversion of the lost mass or the mass defect into energy. So it was noted that the actual mass of the nucleus is less than the sum of the masses of the nucleons forming it. This is because part of this mass, this lost mass, is converted into energy. This energy is called binding energy. Okay. How to calculate this binding energy? By subtracting this delta M is the difference between the mass as calculated and the actual mass. If you subtract them, the two masses, you get the delta M, which is called the mass, lost mass, or the mass defect, and multiply this mass in atomic mass unit, multiply this mass by 931 to get the binding energy in million electron volt. This is the details of this law. Binding energy equal number of protons by the mass of one proton plus number of neutrons by the mass of one neutron. This is, between brackets, this is the calculated mass of the atom, minus mx, which is the actual mass. All this in the bracket is delta m. Then multiply this delta m by 931 as stated here in this law. Okay. Also, you can calculate the binding energy per nucleon. Binding energy per nucleon, Be over A. A is the mass number. Binding energy per nucleon is a measurement for the stability of the atom. As the binding energy per nucleon increases, this means that each nucleon participates more in the binding energy, and this means that the atom will be more stable. But if the binding energy per nucleon is small, this means that the atom is not stable. Okay, this is an example. If the difference between the sum of the masses of the nucleus components of iron atom and the nucleus of the mass is 0.5 atomic mass units, so the binding energy of the nucleus of iron is equal to, of course, multiply, this is delta m, this is delta m, multiply this delta m by 931 to get the answer, which will be D. Okay. Here is another example. If the nuclear binding energy of the helium nucleus He24 equals 28 million electron volts, so the nuclear binding energy for each nucleon in helium nucleus in million electron volt will be equal to, this is the binding energy, divide the binding energy over the number of nucleons. Number of nucleons here is 4, the mass number, 28 over 4, this gives 7, so the answer here is 7. Okay, now thank you.